Okay, for number 13 we have a Ferris wheel problem, 200-pound person, 40-foot radius wheel, and normal force on the person as they're at the bottom of the wheel. Determine the magnitude of the angular speed of the Ferris wheel in RPMs. And we do need a free body diagram, kinetic diagram. Hopefully, been through the class, you've seen a lot of these problems worked. The key or important points were at the bottom of the wheel. There's the normal force, there's the radius, there's the weight of the person. Okay, so we'll have the person sitting at the bottom of the wheel, and they're having fun. Alright. The center of rotation, since we're at the bottom, is up here. Okay. The forces on the person are simply the normal force and the weight. The accelerations on the person is going to be the centripetal acceleration towards the center, m(a) sub n. Okay. Not given any information about the tangential acceleration or the angular acceleration, so we're going to assume constant angular acceleration. Okay, so from our free body diagram and kinetic diagram, we have, if we use positive as upward, the way we've drawn things. Okay, so we would have the normal force minus the weight is equal to m(a) sub n. Normal force is given. Okay, 260 pounds. The weight is given, 210 pounds. Okay, the mass is the person's weight divided by 32.2, and a normal acceleration then can be real easily calculated. Okay, so we'll go ahead and do that. 260 minus 210 is 50 times 32.2 divided by 210. Okay, so that'll be units of feet per second squared, 7.667. So that's the first part of the problem, and then the last part of the problem, or second part of the problem, is to relate a sub n to its angular speed. So we have two equations for angular speed, v squared over r, which we also saw that it's omega squared r. So I'm going to use omega squared r in this case because we're looking for angular speed. Okay, so I can solve for omega here. Square root a sub n over r. So square root of 7.667 feet per second squared times the radius of 40 feet. Okay, the units, feet, will cancel out inside the radical. We'll have 1 over second squared, which is radians. When we take the square root, will give us radians per second. Okay, so that number is divided by 40 and square root 0.4378. Again, radians per second. Almost done. We're asked for the speed in RPMs, so we'll use 1 revolution. It's 2 pi radians, and we'll use 60 seconds is 1 minute. So we'll take our radians per second value, multiply by 60, divide by 2 pi. So times 60 divided by quantity, 2 pi. 4.18. revolutions. Let's see, I'm going to write it that way. Revolutions per minute. Every 15 seconds we do one revolution. Pretty fast Ferris wheel. Key points: free body diagram, relate the normal force and the normal acceleration, and then work with that to get the speed, and then convert to revolutions per minute.